This video covers the Unit 2 differentiation free response. For part A, we have to find the equation of the tangent line when x equals pi over 6. We know that g of pi over 6 is 1/2. G prime of x is tangent 2x minus 1. So to write the equation of a tangent line, we need first the point. And so let's find the point. Well, we already know that. The point is given to us. The point is pi over 6, 1/2. And the slope is, so for 2, to find the slope, we need to do g prime of pi over 6 is equal to the tangent of 2 times pi over 6 is pi over 3 minus 1. The tangent of pi over 3 is the square root of 3. So our slope is square root of 3 minus 1. So we have y minus 1/2 equals the slope, which is the square root of 3 minus 1. Put that in parentheses, and is multiplied by x minus pi over 6. Part B, I meant for this to be where g of x has horizontal tangents. If we were to do that, we would need to know where tangent 2x minus 1 equals 0. That would be where tangent 2x equals 1. On the interval 0 to 2 pi, we know tangent is 1 at pi over 4 and 5 pi over 4. So that means that 2x equals pi over 4 or 2x equals 5 pi over 4. So we get x equals pi over 8 or x equals 5 pi over 8. The reason I did not count this is that if you were actually to tell me where g prime of x has horizontal tangents, you would need to take the derivative of the derivative, because a function has horizontal tangents where its derivative is equal to 0. For C, we have h of x is f of x times g of x, and f of x equals cosine x. So I would just put in h of x equals cosine x times g of x. And so if we're finding h prime of pi over 6, we're going to have h prime of x is cosine x times g prime of x plus g of x times the derivative of cosine, which is negative sine x. And so h prime at pi over 6 is it's the cosine of pi over 6 times g prime of pi over 6 plus g pi over 6 times g of pi over 6 and times the negative sine of pi over 6. So cosine pi over 6 is square root 3 over 2. G prime of pi over 6 is the square root of 3 minus 1 plus the g of pi over 6 is, we know that to be 1/2. And negative sine pi over 6 is negative 1/2. So we get the square root of 3 minus, we get 3 minus the square root of 3 all divided by 2 minus 1/4. And if we simplify this, we get 6 minus 2 root 3 minus 1 all over 4, which ultimately simplifies to be 5 minus 2 root 3 over 4. For number 2, we have g of x is equal to f of h of x. So g prime of x is equal to, we have these graphs too. So we have g prime of x equals f prime of h of x times h prime of x. And so g prime of 4 is equal to f prime of h of 4 times h prime of 4. And so that's going to be h prime of h of 4, 1, 2, 3, 4 is 1. So f prime of 1 times h prime of 4. So if you have a graph that contains a lot of line segments, then the slope at a particular point is the slope of the line segment. So f prime of 1 is the slope of this line segment when x is 1, which is up 1 over 1. So that slope is 1 times h prime of 4 when x is 4, 1, 2, 3, 4. So right here, the slope of this line segment is up 2 over 1. So just times 2. So the derivative is 2. For part B, we're supposing that f of x has a property f of x equals f of negative x, which should tell us that f prime of x is equal to f prime of negative x, apply the chain rule, and multiply by negative 1. So this means that f prime of x equals negative f prime of negative x. And so then we also know that a of x is f of x divided by h of x, and we need to do a prime of negative 1. So a prime of x is equal to, quotient rule, we have low times the derivative of the top minus the high function, which is just f of x, times the derivative of the bottom over the bottom function squared. Now what we're going to do is replace f prime of x with negative f prime of negative x. So this is going to be negative h of x times f prime of negative x minus f prime of x times h prime of x, f of x, not f prime of x, over h of x squared. And so if we substitute in, we're going to do a prime of negative 1. That's going to be negative h of 1 times f prime of, if x is negative 1, it's going to be f prime of 1 minus f of negative 1 times h prime of negative 1 over h of negative 1 squared. So looking at our graph, h of 1 is, I'm sorry, it should be negative 1. For that, it should be h of negative 1 because we're doing a of negative 1. So h of negative 1 is positive 1, so that's going to be negative because of this property here. So negative 1 times f prime of 1, if you look at the graph, is h prime of 1 is, so low d high, so we have negative h of negative 1. H of negative 1 is 1, f prime of 1 is 1, so f prime of 1 is up 1 over 1, so we get another 1 minus f of negative 1 is the same as, so over here we can do f of negative 1 is equal to f of negative 1, which is just the same as f of positive 1. F of positive 1 is 2, so it's going to be minus 2 times h prime of negative 1, the slope is down 1 to the right 1, I'm sorry, down 1, right 1, and h of negative 1 is, we established 1, so it's just over 1 squared. So we get negative 1 plus 2 over 1 is equal to 1. So the derivative, over here we have a prime of negative 1 equals just 1 as our final answer. And for part C, we're going to have f prime of never change the input multiplied by the derivative of the input. So the derivative of f of x is f prime of f of x times f prime of x. And it's going to give us f prime of f of 5 times f prime of 5, which equals f prime of f of 5. When x is 5, we get 1. So f prime of 1 times f prime of 5. And so f prime of 5 is the slope of this line segment at x equals 1. So that's down 1, right 1. So that's negative 1. So this is going to be 1 times negative 1, which equals negative 1. For part A, for number 3, we're trying to find A and B so that f of x is differentiable everywhere. So to be differentiable everywhere means continuous and slopes are equal everywhere. Slopes are equal. And when we say equal, we honestly just mean at the breakpoints. So at the breakpoints. So if the function is continuous, it means that the left limit equals the right limit. So if we substitute in 1 for x, we would get, so you know what, actually let's write this down. The limit as x approaches 1 from the left of f of x equals the limit as x approaches 1 from the right for f of x. That's going to tell us that if x is 1, we get a plus 5 equals, the right limit is going to be b minus a. So from this, we can get, if we manipulate this equation, we get 2a plus 5 equals b. That's one equation. We did all of this knowing the function was continuous. For 2, we need the derivative. Since we said the slopes must equal at the breakpoints, f prime of x is going to be 2ax plus 5 if x is less than or equal to 1, and 2bx minus a if x is greater than 1. And if we substitute in 1 for x in the numerator and not numerator, in the top and the bottom, we get 2a plus 5. And again, the derivative has to exist when x is 1, which means the slopes in this case are equal. So 2a plus 5 is going to equal 2b minus a. Since b equals 2a plus 5, we have 2a plus 5 equals 2 times 2a plus 5 minus a. And that's going to give us 2a plus 5 equals 4a plus 10 minus a, which is 2a plus 5 equals 3a plus 10. And if we combine two steps by subtracting 10 and subtracting 2a, we get negative 5 equals a. So since a is negative 5, we can go over here and find b. So we get 2 times negative 5 plus 5 equals b. Negative 10 plus 5 is negative 5, so b is also negative 5. To write the equation of the tangent line, we can go back. First, we can rewrite f of x. So f of x is, since a is negative 5, we get negative 5x squared plus 5x if x is less than or equal to 1. And if x is greater than 1, we have, since b is negative 5, we get negative 5x squared minus ax. Since a is negative 5, negative 5 is going to be also plus 5x. It's the same equation. So f of 1 is equal to negative 5 plus 5, which equals 0. F prime of 1 is equal to, well, we'll make it f prime of x first. That is negative 10x plus 5. And so f prime of 1 is negative 10 plus 5, which is negative 5. So the equation of the tangent line is y minus 0 equals negative 5 times x minus 1. And last is number 4. We're given h of x is f of x squared and this information. So we need to write the equation of the tangent line for h of x when x equals 3. So h prime of x is 2 f of x times f prime of x, and h prime of 3 is 2f of 3 times f prime of 3, which is 2 times negative 2 times 4, which is negative 16. So this is for the slope. And then for the point, we need h of 3 is f of 3 squared, which is -2 squared, which equals 4. So the equation of the tangent line is y minus 4 equals -16 times x minus 3. For letter B, we already know that h prime of x is 2f of x times f prime of x. So we have to do the product rule to get this derivative. So h double prime of x is going to be 2f of x times the derivative of f prime of x, which is f double prime of x, plus now f prime of x times the derivative of 2f of x, which is just 2f prime of x. And so then h prime of 3 is going to equal 2f of 3 f double prime of 3 plus f prime, we'll put the 2 in the front, so 2f prime of 3 times f prime of 3, which is 2f of 3 is -2, and f double prime of 3 is -1, plus 2f prime of 3 is 4, so 2 times 4 times 4, that's 4 plus 16 times 2 is 32. So this equals 36. And last is it necessary that h of x equals 2 on the interval 3 to 6? Well, this is just a throwback to the intermediate value theorem. H of 3 is going to equal f of 3 squared, which we previously established was 4, and h of 6 is f of 6 squared, which equals 3 squared, which is 9. And the answer is no, 2 is not necessarily between, we'll say necessarily on the interval f of 3 equals 4 to f of 6 equals 9. All right, so that concludes this video. Thanks.